Hello everybody and welcome to me talking about variables. As per usual, just a reminder that I am a real human being sitting here doing programming with you, but really all of the action's on the screen, so let's go back there, shall we? Here we are. Okay, so the thing that I'm going to do right now, just because this is the first video in the series for this week, is before I talk about anything at all, I'm going to set up an activity, a sort of sandbox project, right? Like I did last time we were here. So the thing I'm actually going to do first of all is I'm going to go find my repository on my computer. Oh gosh, I've got a lot of folders called Cart253. I think this is the one here. Yes, so this is my GitHub repository here, Cart253. And I remember last time when I was talking about drawing, I made a drawing experiments project so that I could type code in. And I suggest that we do this every time that we're covering lecture material. So to start a new project, I'm going to go over to my browser and I'm going to go to the course homepage, github.com/myname/cart253-2020. And I'm going to head to templates here, and I'm going to download the zip file with the template in it. I'm going to do this every week. Obviously, it's going to become second nature for you as well as for me over that time. But it's still worth kind of reminding ourselves that that's what we're doing. Okay, so I know that that ended up in my downloads folder, so I have to go find my downloads folder, don't I? Downloads folder. There's my template. So I'm going to drag that zip file over here into my repository folder, just like last time, just like every time. Unzip it by double-clicking on it on my computer. I'm going to delete the zip file. You can do that by selecting it and hitting Command Delete if you're using a Mac. There's probably something similar for Windows. And I'm going to rename it to Variables Experiments. It's a good name for it because that's what it's going to be. I guess I could also have just duplicated the drawing experiments one and then changed the file so that it didn't have the other stuff in it. I kind of like starting with a very fresh template each time, so I'm going to do it that way. And then I'm also going to open up Atom. And obviously, you should be following along, but you can always pause if I'm going a bit too quickly or anything. And we want to open that folder that we just created in our repository. So I'm going to go to File, Open, and I'm going to go find my GitHub, which is in Documents, GitHub, Cart253, Experiments, Variables Experiments. Remember that you should always be opening the folder that contains your project in it, not the entire Cart253 folder, not your Documents folder, not your GitHub folder, but just the one that contains the project that you're working on right now. So Variables Experiments, and I click Open. Okay. So there we have it. That means I can go into the JavaScript folder and click on the script, and I've got my place to do some work on this project right now. Okay. I also want to open GitHub Desktop because I've just added something, and I'm going to commit these changes that I just made. So I'm just going to write started variables experiments for class. And I'm going to commit that. And again, I don't have to push now. Maybe I'll leave pushing for the moment. Just that might help me remember to keep committing as I go. Back to Atom. Okay, so the thing that I want to talk about today is this idea of variables. And in order to talk about variables, we need to start writing our programming instructions in more than one place. So last week we did all of our code in setup, right? We did that to draw stuff. And we did that just because setup, it executes the code in at one time, and we were just drawing something one time. So for instance, we might do create canvas. My my favorite 500 by 500 canvas, for instance. And then we were doing everything else in here, right? Like we would draw a background and draw some ellipses and what have you. But today what I want to do is I want to start doing some programming inside this draw function, the second function that's on the screen. And the draw function is really where the action is in P5. And it's sort of where the action is in programming in general. You'll find some version of this idea of a draw function. It's often called an update function in a lot of environments. This function, even though it looks like it's just one thing, and it is just one thing, the great thing is that it gets executed or run, the code inside, it gets run once per frame that your program is running. So if our program is running at 60 frames per second, which it generally is, everything that we write in here, the code in here, the program will go through the code in here and run it once every 60th of a second. So very, very quickly over and over and over again. So it's a loop, right? It's often called the draw loop for that reason, or the update loop. So we can do the same thing. We can write drawing instructions in here. A red background there with 25500, all the red. I'm going to use rect mode center, so as I'm going to put a square in the center of my screen, and I'm going to use rect 250. 250 is the center of the screen if the canvas is 500 by 500, which it is, and I'm going to make it 100 by 100. So just a nice simple program that will display something on the screen. And I'm going to go up to Packages, Atom Live Server, Start Server. Jumps across here, and I have what I wrote in, right? We have a red background and a default square, which is colored in white with a black outline around it. So it's sort of a bit silly because it's exactly the same result that we would have had had we run this code in setup. But the reason that it's not changing, right, is that there's nothing in this code that's going to be any different. So what's happening is this code here, background sets to red, rect mode sets to center, draw a rectangle in the center of the screen. It is being run 60 times per second. Like each of these things runs in a 60th of a second over and over again. But because they all do the same thing every single time, we don't see any difference, right? If I go back to the browser, you can imagine this is being rendered over and over and over and over again, 60 times per second. But because it's always the same thing being rendered, we don't see any differences. It's like if a movie only had one picture in it that it just displayed over and over and over again, right? You wouldn't perceive any motion or anything happening. And in order to kind of get around this problem, we need some way of making stuff change inside that draw loop. So we want stuff to actually change inside here. And for anything to change, what we need is variables. That really is at the heart of programming that allows change. And all that a variable is a way of giving a name to a number or some other kinds of values, which we'll talk about later. You're giving a name to something that has a few advantages, but the main thing is that once something just has a name, it can change in programming. And for this video, all I want to do is talk about variables that already exist inside P5, okay? So for this video, we're just going to look at a couple of the greatest hits of built-in variables. And the greatest of the greatest hits are these variables called mouse X and mouse Y. So I'm going to type them in here just so you can see what they look like. So instead of 250, 250, I'm going to say that I want to draw this rectangle at the position that is defined by these two variables. So these are the two names. Mouse X, notice that the X is big, and mouse Y, notice that the Y is big there. That's something we'll talk about later. So instead of writing 250, 250, which is a specific location that can never change, now what I'm saying is use the number inside this variable called mouse X for the X coordinate of my rectangle, and use the number inside this variable called mouse Y to control my rectangle's Y location. And the beauty of this variable, mouse X, and this variable, mouse Y, is that they can change. And as you might imagine, what's inside these variables is the current location of the mouse. So if I move my mouse, the numbers inside these two variables are going to change, right? And that's all that I'm going to do. Let's go look at how different the program is now. So we're just drawing the rectangle at these variable locations instead of at 250, 250. But now, as I move my mouse around on the screen, you can see that the rectangle is always being drawn with its center, because we used rect mode center, where the mouse is. And because every single time through the draw loop we redraw the background, which covers up whatever used to be there, and then we draw the rectangle at the mouse location, we have our first interactive program, right? Pretty exciting, actually. So we can move this rectangle around using our mouse because the rectangle is drawn based on the mouse location. It's a very small change. All we did was replace two numbers with two variables, but the program is radically different now, which is really pretty exciting. I think it's kind of wonderful. So you can imagine as this runs, the number inside mouse X, mouse Y is changing over time. So if I were up here, mouse X and mouse Y would be close to 0, right? That's the top left. As I move it across to the right, you can imagine mouse X is getting bigger because the mouse X location is moving to the right, which is larger. And as I move down, the mouse Y is getting larger as well. That's a very cool effect. Also a cool effect is if we don't fill in the background. So I'm going to remove this line of code. Note that one way that people often remove lines of code temporarily is that instead of just deleting it, I could obviously just delete it like that and it would be gone. A nice thing to do if you don't want it to be gone forever is to comment in front of it. So if I put 2 forward slashes in front of this line of code, you can see it turns gray and it's no longer part of the program because it's now being treated as a comment. That's what those 2 forward slashes mean, remember. So if we don't redraw the background, it means that we're going to see everything that was in the previous frame and the previous frame and the previous frame. Maybe you can imagine what that looks like. Here we go here. So there's no background, so we see white. And we can see that every single frame, a rectangle is being drawn in the mouse location. And what that looks like is kind of a drawing program. It's pretty beautiful, actually. Like, I'm always surprisingly obsessed with how nice this looks to me. I could probably just do this all day. Because we get to see all of the previous frames, because they're not being covered up by that instruction to redraw the background, we get this drawing program. The faster we move, the further it moves each frame, and so we get greater or lesser distances between the rectangles between frames. Okay, so it's a drawing program. The only thing I will say is that this is a really cool effect, not redrawing the background. It looks cool in other sorts of software as well. You can do things like this with Unity, for example. It's actually generally very inconvenient to do things this way because anything in your program that moves from frame to frame is going to leave a trail behind it. And that's almost never what you want to do unless you're doing it on purpose, right? So generally speaking, it's pretty normal to cover the background at the start of the draw loop so that you can draw everything freshly for a new frame. We'll see later, you can also draw an image in the background instead of just a color, but it's very common to cover the background as your first action in the draw. So every frame starts with a fresh canvas to work with, okay? All right, so that's the mouse X, mouse Y thing. They contain the numbers that represent the position of the mouse. And it allows our program to change over time. The draw loop is now doing something because those values are changing. Now, one really important thing to know about variables, and it's really important and potentially very fun to think about this, is that these are just numbers, right? We know that mouse X and mouse Y, they have a meaning. Like, we know that it means the location of our mouse, and that has certain implications. Like, certainly using mouse X and mouse Y as the position for our rectangle makes a lot of sense, because we're used to controlling the position of things with our mouse. But the values inside here are literally just numbers, right? If we're in the top left, it's 0, 0. If we're in the middle, in this particular program, it's 250, 250, etc. Those numbers are arbitrary to the program. It doesn't mind where you use them. So we could actually use these numbers absolutely anywhere. So if I replace the position to just a static position, and instead I say I want the dimensions of my rectangle to be mouse X, mouse Y. Now we're using those numbers in a slightly weird way. It's a little bit stranger to control the size of something with the mouse position, but not that strange. If we go and look at what that looks like now, as I move my mouse towards the top left, which is 0, 0, my square gets smaller and smaller until it would eventually fade away to nothing if I could get there to the very top. You can see it's just 1 pixel now. And as I move towards the bottom right, it gets bigger. And it also works on the 2 dimensions, right, because they're independent. So this is a way of resizing something based on the mouse. It's no longer as obvious what the connection is, like it's not just that it moves exactly where the mouse is, but we know that we are still controlling one of the arguments that the rectangle uses, its width and height, with the numbers that tell us where the mouse is. So there's a lot of potential in just using variables in random or interesting places and seeing what happens, right? So let's go back to 100, 100. We can look and see where other numbers are here. There are these numbers, but we can't use variables to control the size of the canvas because this isn't set up, right? It's only going to make sense to use variables to do funny things inside the drawer. So the other place that we have numbers is the specification of the color of the background. So we could say mouse X, mouse Y, for instance, and 0. So now we're saying that we want the background color to be based on the position of the mouse, which is getting pretty weird, but it's still worth trying these sorts of things. It's always worth playing around and seeing what happens. So if I go back here, as I move the mouse around, you can see different colors based on where on the screen my mouse is based. So that's nice as well. So that's something you could just throw in for visual interest if you wanted to. And importantly, you can use these same variables in any position and over again, right? So I could use mouse Y, mouse X, mouse Y and mouse X for the rectangle, and then I could use them again for the size of the rectangle. I could also do mathematics with them. I could divide mouse X by 2, for example, so that everything is being controlled by the mouse location. Now this is pretty random. I don't actually know what this is going to look like, but let's take a quick glimpse. So as I move the mouse around, it's getting pretty weird. The thing is not behaving in a very controllable way, but you can kind of reason it out, right? We know what the background did. It's changed a bit because of that extra argument that I added. We can see that the position is that it moves to the right as I move down, and it moves down as I move to the right because I reversed mouse X and mouse Y. We can see that the dimensions are also changing in the way that we saw previously. So we've got a pretty weird looking thing now. We can have a dance party if we want to as well. So that's all just from using variables instead of numbers, right? So variables are super powerful. They make our programs interesting, basically. And variables, they do 2 basic, very important things. The first thing is easy to overlook, but it's a huge benefit, which is that they give names to the things in our program. So if I change this program back so it's a slightly more sensible looking thing. So let's get back to there, and let me just use mouse X and mouse Y in the rectangle position again. That's the sort of the most obvious thing we might do. Because these have names now, we actually know a lot just by looking at the code. We know a lot about how the program works, what it's going to do, because we've got names here instead of numbers. We know definitely, as people who can read code, that we're getting a rectangle and its position is going to be the same as the mouse. And we can tell that just from the variable names. So variables giving names to numbers is really helpful in terms of being able to read our programs and understand what's happening. And then, as we saw from the different uses of mouse X and mouse Y just now, the most exciting thing about variables is the fact that if they change over time, and we're using them inside our drawer, which is happening over time as well, we see dynamic things happen in our program. That's very exciting. So that's what variables are. I just want to introduce a couple of other variables that are very common that we probably want to know about. The most common variable that we end up using that's, again, built into P5, it's already defined for us, we don't have to do anything extra, is the variable called width. So there's a variable called width that will always have the width of your canvas in it after you've created your canvas, and a variable called height that will always have the height of your canvas in it after you've created the canvas. So for instance, if I wanted to draw my rectangle right in the center of the canvas, I would set its position to be the width divided by 2, because we want it to be in the middle, so we have to divide the width of the canvas by 2 to get the center horizontally. Same thing for vertically, we divide the height by 2 to get the center vertically. Now I know, without needing to actually check what size the canvas is, that this rectangle will be drawn in the center. Let's go and check that quickly. Indeed, there is my rectangle in the center, hardly surprising. We kind of knew that would happen. But the great thing here is, again, we can now look at this and we know what it means. We know that width over 2 and height over 2 are the middle of our canvas. We don't need to look up here to see what the width and height are. It doesn't matter. We know that we're using whatever it is. The really useful thing about that, of course, is that if we do change the dimensions of the canvas, say I make it 800 by 800 instead, or 800 by 500, let's say, the square is moved in the sense that it's now still centered, right? It didn't stay where it was previously. So the canvas changed and the square moved. It's a little bit like responsive CSS, for example, when we're talking about web pages. It's centered in a specific way, in an algorithmic way, if you like. If we had our previous way of centering it had been to use 250, 250 based on the canvas size, then it wouldn't be centered anymore when I changed the width of the canvas, and I'd have to go back and figure out again, oh, now this needs to become 400 because I changed the canvas, then it's centered, but then if I decided to change this back to 500, and I go back again, now it's not centered, and so you can see how it could be really irritating to have to keep checking the canvas size in this instance if I want to do anything relative to it. Whereas width over 2, height over 2, using the width and the height that are in these variables, this has got 500 in it, this has got 500 in it as well, because that's what these are set to. This will end up being 250 and 250, so it will do the calculation for us, and that's what computers are for. The final two variables that I will introduce, just because I know that people like them, are window width and window height. So the most common place that people like to use these is in Create Canvas, actually. Window width and window height. You can probably imagine what is inside these variables, but let me tell you. Window width contains the width of the window, so the whole area that's inside your browser window that's available to display things. The width is inside this variable called window width. The height is inside a variable called window height. Notice the capital W here and the capital H here. Again, we'll talk about that later. If I use these variables instead of typing in just numbers here, what is guaranteed is that when I go back to my canvas here, we can see that it's now taking up the entire width and height of the available display area, which is super nice. And again, because I used width over 2 and height over 2, when I drew my rectangle, the rectangle is still centered. Now, if I had a slightly different sized window, like this, for example, and then I were to reload the page, because now things have changed, so I want to rerun my program, you can see, again, it's taking up the full size of my window, and again, the rectangle is centered. Resize it back out to the full width of my screen, reload the program, and again, we end up with the full amount of the window being taken up. So, pretty useful thing to know. It's very satisfying to have programs that take up the entire window, I find. It's a lot of red. So we've done a lot in this video. Let me go and quickly commit. I'm going to say learned about using built-in variables in GitHub Desktop. And I'm going to commit that to my master. And now I've got 2 commits to push, but I'll just leave them there for now. So we've learned about this idea of variables, which are just names that we use in our program that have numbers inside them for our purposes right now. And they have numbers inside them that can change. And they have sensible names that describe what's inside them, right? So window width has the width of our window in it, and height has the height of our canvas in it, and mouse X has the location of our mouse in it. And when we use those variables and they change while our program is running, we end up with programs that can actually do something interesting, like flash red, as if there's an emergency. So our programs are no longer static things where we just draw something and that's that, even though that is super cool all on its own. Now our programs are dynamic, and there are so many new possibilities with this new ability. So it's pretty exciting. I'm excited. I don't know about you, but I'm excited about that. So here's my face again, I believe. Be embarrassing if you can't see my face right now. So in summary, we know that our draw function that we started using in this video is executed 60 times per second. That's important to remember. It's happening over and over and over again. It's not just a one-time thing. And we saw that if we use variables inside that function, because those variables change their values over time, or a lot of them do, we can see things happen in our program. And we also just saw that variables give names to numbers so that our programs are easier to read and can just make a lot more sense, both to ourselves and to the other people encountering our work. So that's it for this video. Hopefully that was useful, and I will see you in the next video.